Okay, we're moving into Unit 6, which is called Systems of Equations. What you're going to be able to do today is solve a system through graphing. That's what you can do today. In a system, I will define it here in a minute, is technically two lines. And if you solve it, it means you find where they intersect. That's what that means. So a system is two or more lines that may or may not have an intersecting point. Notice that prior to starting this lesson, we did 3 of them. One, they intersected. The other one was parallel. They didn't intersect. And then the other one was an intersect. Solution means answer. So you could just put answer. If I say solve the system, it means tell me the answer. And when I say an answer, well, you have 2 graphs. What do I mean by an answer given 2 graphs? It's a point on a graph that satisfies both lines. Satisfies, I'm putting that in quotations. Satisfies means it makes it true. It's true on both lines. A solution is where they intersect. So a solution to a system. System means more than one line. Solution means where do they intersect. It'll always look like this. You're always going to have an X and a Y. So you have to tell me what point do they intersect. That's what you're going to have to do. So you graph it and then tell me where they intersect. That's the solution. That's the answer. So what you did earlier, you would have found the dot that they intersected at and wrote that value there. Steps, make sure it looks like this. That's why we graph. Everything that you're going to do is going to look like that. I'm not going to make you change anything. Then you need to graph them. And then you're going to find out where they intersect. You're going to determine the intersect point. So your answer will look like that. It's a point. A solution is a point. Okay. So this page I don't really love that much, but I need to teach it to you. You can always check your answer if you're not sure if they intersect at the particular point. Let's say it's not perfect and you had to make a guess. You can always check. And it's tedious, but what you do is plug the X and Y in and see if they're true. Now I'm going to go ahead and check to see if the point 2, -1 is a system to, or is a solution to the following system. System just means more than one line. So here I have 2 lines, and I want to know, is 2, -1 on both of these lines? If it's on both of those lines, it's where they intersect. Okay? So x is 2, y is -1. First equation. 3x plus 2y is 4. That's just the equation they gave me. Now I'm going to put 2 in for x, -1 in for y. So 3 times 2 plus 2 times -1, does that equal 4? Does 6 plus, order of ops, does 6 plus -2 equal 4? Yes or no? Yes. So that point is on that line. That's what that tells me, is that point is on the line. Now I got to check my second equation. And you won't have to do this today. This is just in case you like to check your work. So here's my second equation. The point was 2, -1. So I'm going to put my 2 where the x is, my -1 where the y is. Does -2 plus 3 times -1 equal -5? Hey, don't forget to multiply first. Don't do -2 plus 3 first. Kids will do it. Don't do it. Order of ops. So -2 plus -3, does that equal -5? Yes. So that means that this point is on both lines, and if it's on both lines, then it has to be their intersecting point. That's what that means. Alright, that's lovely and tedious. Let's just graph. That's all I want to do. I just want to graph. Ugh. Okay, you will not have to get y alone first. Just so you know. I would never give it to you where you have to get y alone. So I'm going to help remind you because some of us struggled with that on that test. First thing I would do is subtract x. So y equals -x plus 3. That's line 1. Second one, I would plus x. So y equals x plus 1. That's getting y alone. That's what I've been telling you to do. Because I don't want to graph if y isn't alone. So now I have 2 lines. I don't know if you like it this way or right on top of each other. I'm going to prefer to bring this down so I can look at them both aligned. So this is y equals -x plus 3. And now I'm going to graph both lines. So this is 1 over 1. So I intersect the y-axis at 1, and then I go up 1 over 1, up 1 over. Or down 1 over. So there's that first line. Second line, -x plus 3. So I'm going to do a different color. So I intersect the y-axis at 3, so I'm making a dot at 3. That's right there. And then this is where you need to be careful about negative slopes. Because a lot of kids forget that you need to go down and over, and all of a sudden you'll say, hey, they don't intersect. That's probably because you did your slope wrong if they don't intersect. So this is down 1 over 1. So down, over, down, over, down, over. Do they intersect? Okay, now I have to say my answer. The solution is the point they intersect at. What point do they intersect at? 1, 2. So that's the solution to the system. Okay. I'm going to go ahead and get y alone. You don't have to, you can just write the final answer, but I do want you to observe me getting y alone, because a lot of kids still struggle with that. So, let's see here. I would minus 3x, and I get 2y. I need room. Okay, I'm going to make a t-chart. Do you have any idea why I did that? I did that because I needed room to get y alone. Okay, you will not have to get y alone today. 3y equals x minus, I bet you I meant for this to be, I don't know what I meant that to be. Interesting, it shouldn't be 5. Y equals 1 over 3x minus 5 over 3. See why I don't like that? You should have perfect points. At this level of solutions and systems, you should have perfect points. So here's your 2 lines. So this is what I want you to write down. Those are your 2 lines you're graphing. You plot them. Don't forget, negative slope means go down and over. Down 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Or up 1, 2, 3 over 2. And I really don't love this next slope. Or that next y-intercept. What's 5/3? That's a repeating decimal. Kind of close to 1. Or -2. Yuck. Okay, so I'm kind of close to -2. And then I go down 1 over 3. No, just kidding, I go up 1 over 3. So up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And they intersect somewhere. I don't expect you to find it, because you don't need to know that part yet. All I want you to do is graph normal lines that they have a perfect intersecting point.